All right, if you're back, that means you were able to get RStudio installed, R installed, and then RStudio, and everything's open. So now we're going to learn this RStudio interface. So this is the interface, and there's four things I want to show you. There is, let's see, there we go, script, the console, terminal jobs, environment history, connections tutorial, files, plots, packages, help, and view. And they're divided into four different segments on your screen, with the exception that scripts doesn't appear by default. So there's three sections to start. You've got this on the left is your console. So the first one doesn't show up right away. You have your console, your terminal, and background jobs. These last two tabs we don't really use until you get more advanced in R. So really what you're doing, this console, think of it as what we just were using snippets for. So if I type things in here, I can type in code and then press enter to run the code. Okay. We're gonna do this all in just a moment. On the top right is your environment. This is new. The environment is where you save things to. So any objects or variables that you save in RStudio is going to show up in your environment. So that's really helpful. So it's like almost like what are your files within R? The history tabs sometimes we use. You can see I was doing some other stuff here. I'm going to clear that. You don't need to know how to do that, but there's nothing here right now because you should have not run anything in RStudio at this point. So history is just a history of code. Connections, there's some stuff you could do there later. Tutorial, there's some nice packages that you can use to learn how to use RStudio, which I'm not going to really go over since I'm kind of running the tutorial here. On the bottom right, you've got files, which is a bunch of things, let me think of it this way. Files is like your window into your actual computer. So my actual computer, if I go to my file explorer, okay, and if I go to home, and if I go to my documents, and if I go to R, like literally on my computer, I will see these files, right? This is me doing stuff. And that is exactly what I see in the bottom right on RStudio. So it's a window into your computer, which is what we use to then load data sets and things like that. Plots we'll get to later. That's where we'll see plots, well, visuals. Packages we'll get to later. Think of packages like applications on top of R. So they're things you can add on top of R, basically. Well, again, we'll get to all that later. Help is a really useful place where you can look into, well, how do you do things? We'll get to later. And then we don't really use the viewer in presentation very much. So that's a very quick overview. I've got on my slides kind of a breakdown of what it looks like, but at the time I used a blue version of this, so don't worry too much about it. So here's what I'm also going to start off with, because I want to teach you how to best run R effectively on your computer. There's lots of different ways to do it, but the first thing I'm going to show you is how to create a new project. So when you open this the very first time, right now it says R-RStudio, and you might actually have untitled project. You probably have untitled project here. What I'm going to instruct you to do, please do this along with me, is click on new project. You click here, new project, or you click file, new project. Both are the same thing. What a project does is it creates almost like a folder where you can store all the things, scripts, files, multiple scripts for in history and environment for the same project. So that way you get things yourselves organized. So what should be happening is it should be opening up new project tab for me, but for some reason it's not opening. There we go. Okay. You should get this come up. It should be a new project wizard, and it's going to ask you, do you want to create a new folder on your desktop or an existing folder? And it's up to you. I'm going to choose existing because in previous videos, you should have heard me say, oh, you should create a folder on your computer to store everything related to this class. So that's what I'm going to ask you to do. I'm going to ask you to go find that folder again, which for me was under classes, documents, classes, intro stats. So I'm going to ask you to go to your computer and find that folder that you created for intro stats that has the files, that has Excel, it has maybe multiple folders underneath with the different weeks or modules or whatever, however you want to organize your notes. Go to that space and find that folder and click open. What you are doing here is you're creating inside the intro stats folder, you're creating an entire project for R where you can store all of your scripts and get yourself organized. And that way, everything's in the same place. And then in the future, if you took a different class in R, I would recommend you do the same thing. You create a new project and go to that class's folder and put R there and do exactly what we just did, because then you can then get all your scripts, your files, and everything associated with that class in one place. Or you can do it for projects. So I do it project by project. So I might be running a research project on leadership, and I'll call it Leadership Study in 2025 about this. And I'll create an R project for that research project. And that way everything is organized in one place. I recommend you do that for several reasons that will be clearer later. Right now, it might be a little unclear why you do that. Now, so again, I'm doing it this way because I've already created the folder in my computer titled intro stats. You could do it this way, where you click on new directory, new project. Notice there's a lot of things you can do, which a Shiny app and stuff like that, which we won't get into here. And then we can name it intro stats, and I can find a place to put it, and it will create an entirely new folder for it. I'm choosing not to do it that way. I find it personally easier to create the folder on my computer, especially because I probably already created it to put the syllabus in there, to put files in there and stuff like that, and go find that folder and click Create Project. So it's noticing it's taking a moment. It's going to switch that project. And now, after my gray screen loads, I don't know why it's taking so long to load. My apologies. Um, After my gray screen loads, you should get it looks the exact same. So everything is the same. The difference now is look in the top left and the top right. It's now the intro stats project. And by the way, notice I've got a lot of projects here. That's where, like I said, I do a different project for each class, each research project, and things like that. And notice this is where you start seeing the advantage of doing it this way. Under files, I have now defaulted, by default, it goes automatically to that folder where now if I navigate to the folder, for example, on my desktop, I'll see that it's now created an intro stats R project here. And you can see the HR data set that we're going to open in just a second is here. That's what we downloaded earlier in a previous lecture. You downloaded and save the file here. You might have your syllabus here, your class notes. You might have another folder here that says, I don't know, week one, or maybe let's say homework, and you have your homework assignments in that folder, which is great because now I'll go over here. Look, I can go into that folder and I can open stuff, assuming it's in there. So maybe I put my homework one data set in there. So I can click on it and open it here, which I'll show you in just a moment. And I can click this little right arrow to go back up a level to the previous folder. So it's nicely saved in one spot. And if I ever close R, so if I close out of this, then I can go back to my file folder here and double click on intro stats and open it up and continue where I left off. And that's wonderful because, oh, what if I jump from here to a different project? Well, if I'm doing it all in like a completely different class or project, if I'm doing it all in R, I might get confused. Like, oh, my history shows something I was working on for here, and then I open it again, it's something here. This way, it's all one area. So all of my environment, my history, my files to this class are in this R project. And if I switch over to a leadership project, when I open the R project for that leadership project, I got my files, my scripts, my history, and my environment only for that project, making it a lot easier to organize your materials. So that's a recommendation. To be very clear, I'm not requiring that you do it this way. I just strongly recommend it, especially if you're not yet used to organizing files for data science and for statistical programming. Doing it this way will probably help. Sorry about that. I have a light that makes it easier to see me that just fell on top of me. So doing it this way makes it a little bit easier to organize your files. I strongly recommend you do this. Okay, so what's next? So I said do that, and then I now am going to open a script. Is the other thing that I strongly recommend you do, and you will be required to do this for different homework assignments. Click on File, New File, R script. Notice, look at how much stuff you could do. You could code in Python, you could do CSS, C++. There's so much stuff you could do. But I'm going to stick nice and simple and open an R script. Scripts are documents where you can save your code and rerun it to share with others. And so in my slides, I have do this now. I'm asking you to do this. I did actually cover new project. We're not going to cover R Markdown in this class at all. So you're going to be required to turn in your script. You'll be required to turn in your script for any homework assignment. So right away, go ahead and open a new script, and let's go ahead and save this. And I'm going to do, I could do Control S, or I could do File, Save As. And notice it's defaulting to that folder. So this is what I meant by it's just nice and simple. Everything is in the same folder. And I'm going to call this video 1 or something like that. You might call it homework 1 if you're working on the homework script, or homework 2 or whatever. The point is the script needs to be named something because you will turn this in. You're required to turn this in, and go ahead and save. And notice, you can see it here in the files, you now have an R script and it's on your computer. So if I open my computer, here's a video 1, it's a .r file. There's a video1.r, and a .r file is an R script file. You will be required to attach that when you submit any homework assignment, in addition to your write-up or any, like, here's the answers. The script tells me as an instructor what you actually ran to get your answers. And you're required to not only get the right answers, but also do the script correctly so that you show you know what you're doing when you're coding the language. So inside this script, you can start typing code, okay? And the whole point behind this is that, so every time you open R, you start RStudio, you start fresh in the sense of you run the code from top to bottom. And so this idea, we're going to learn more about this as the term progresses, but the idea behind R scripts is that they should be reproducible. You should be able to go from beginning to end. Any computer should open your script and have your data set and be able to reproduce exactly what you did for your analyses. That is the biggest and most important advantage in R. The second biggest is it's efficient, it's easy. Once you get used to things, it's a lot easier to run things. And that's so important because everything you've done, everything you might do in Excel or SPSS, I don't know if you've ever experienced this, like someone gives you an Excel file, it's like, what did they do to it? They formatted something, I have no idea what, and then something sorted weirdly, you don't know what they did to it. In R, it's never like that. If someone gives you a script, they're telling you exactly what they did. And you should be able to reproduce exactly what they did using the exact same code. And that is crucial to R. And so writing code is all about making it easy to understand and clean. Now, this idea of clean code we'll get to later, and something that just you'll want to practice with. So let me circle back to that. Let me now go to the console. So here, I'm going to go ahead, and this is where your code is run, and your results are shown for you here. So let's go back to the very beginning and assign the number 4 to the variable or object x. So x is assigned 4. Do you see how I'm typing it in here? Then press enter. And oh, let's see what happens. So top right, this is what I meant. Now your environment shows that I have saved a new variable or object x, and inside is the value 4. So it's like almost like a window of what are the things being stored in R. Then if I just print x here, I'll get the number 4. So the console is where you can type in anything. You can now say, oh, I want x to be 10. By the way, notice my top right, the environment changed, and now I'm going to print x to the 10th, the second power. So I print 100, but notice my environment, remember we talked about this? X is still 10. I didn't overwrite the file to be x is 10. So think of your console as your play space, if you will. So it's where you're starting to get used to playing with code and trying out different things. Once you've decided this is the correct code, so to be very clear, as you're working on homework assignments, you should start here. You should start here saying, should x is going to be, what was it, 33? I'm just making up numbers, okay? So you can follow along if you want, and I'm just making up some numbers. So x is now this vector, and I want to do the mean of x. Okay, 32.6. And I'm confirming, okay, that's the correct code. That's what I want. Once I know it's the correct code, then I can save it to my script. So I'm gonna now save this, and I could copy and paste this. So I could grab this, copy it, and paste it up here, and then go ahead and do the mean of x. And then notice this red means it's not saved yet. So I'm going to do Control S to save it, and that goes away. So now it's saved. So now anybody with RStudio installed can open this script and put their cursor here, highlight this, and click Run. And notice it pops down here into my console. So it automatically runs that code, and then highlight here and click Run, and it runs that code 32.6. So do you see what I mean by reproducible? So if someone asked you, find the mean of 33, 55, 2, 31, 30, and 41, and you tell me the answer is 32.6. Well, I don't know what you did to get there. This is a really simple example. Obviously, anyone can pull up the calculator and figure it out, but you'll see later why this is so important. Now with the script, I can see, oh, I see what you did. You assigned the vector 33, 54, 2, 33, 41, the variable x, and then you got the mean of x. And that's great because then I know you definitely got the mean and not like, for example, maybe got the median instead. So I can run, and here's a few keyboard shortcuts as you get more used to R. So rather than highlighting this and clicking run, what I can do is I just put my cursor anywhere, literally anywhere in that line, and press Control Enter. And it runs that line of code. And notice my cursor automatically goes to the second line of code. So without touching anything else, I can just hit Control Enter again. Now I get the median of x is 33. And you could do multiple lines of code at once. I could highlight both and click run, or just do keyboard shortcut Control Enter, and it will run both lines of code in sequence. Okay. So that's what I was doing here. We talked about environment. Okay, now let's get a little bit more interesting. So I'm going to go ahead and get rid of all of this. Okay. Here's where R really shines. We're now going to finally open that data set that we were working on last video, the HR data set, import it into RStudio, and do stuff with it. Okay. So just as a reminder, if you go to the files, this is where you downloaded it from the learning management system, and I told you to save it to the same folder on your computer, in this case, the intro stats folder. Not anymore. And so here's that data set. You should remember this data set. This is not your homework data set. This is just a demo data set of employees with 311 employees and employee ID and all this stuff. Okay. Not going to save any changes. So how do we get this into R? Okay, we got that data set. How do we get this into R? There's several different ways to do it, several different ways. I'm going to show you one way that I prefer, and you can find different ways as well. You might look online and they'll tell you, try it this way, try it this way. And let me just say now, in R, there's usually 10 different ways to do the same thing. Usually. The basic stuff, there's only one way to do it. But a lot of the time, there's lots of different ways to do the same thing. And so I'm going to show you how we do it, but it's part of your task to understand the pros and cons. So what we tell you is how we recommend that you do it. But oftentimes, especially if you start Googling, Google is kind of helpful with R because it will tell you what to do. Like if you use ChatGPT, it's kind of helpful to tell you what script to use. But often it's also confusing because, once again, there's multiple ways of doing things. So it might tell you a different way than what we're telling you. And then the two methods might clash and you might get the wrong answer. So be careful when using online resources. They're sometimes helpful. We're trying to give you very clear instructions early on as you get started in R to learn what to do. So, okay, how do you open a data set? I find the easiest way is to go to my files here, click on the data set, and click import data set. Nice and simple. And it's going to give me a nice preview. Okay. And then, no, so this is previewing the data set, looks exactly like we did in R. It's going to ask me, what do I want to name it? So this is we're naming it the object or variable. So we're literally saving this data set, the entire data set, to an object or variable in R. And I'm going to leave it as HR underscore dataset, the default. You can name it something else. Maybe you name it homework one, homework two, whatever you're working. And here's the preview. So it's a little point and click here. This is a nice thing. It has some point and click, but under the hood of the point and click, it's telling you, oh, I'm going to run these 3 lines of code. That's what it's having me do. And so I'm going to grab this. I'm actually going to copy this. I'm going to highlight it and do Control C to copy it. And then I'll go ahead and click import. And notice what it does is it imported the data. So notice, I'll get back to what this library REEADR is in just a moment. But it imports the data set using, here's a new command to learn, new vocabulary, read underscore CSV, read underscore CSV. And it tells me, here's the file. Depending on where you saved your data set, whatever's in the quotation mark may be different. It may be lectures slash HR dataset. It may be homework slash one slash dataset. Maybe week one slash homework slash one slash dataset. It depends on where you saved it. So I find that this way is easiest because I just navigate to the file and I click import, and it automatically gives me the correct code to import the dataset and then view it. And be careful, it's a capital V, not a lowercase v, view the dataset here. And notice it's now up in the top right. So it's telling me HR dataset. It's actually a Tibble. We'll get into the differences there. Don't worry about it. And it has 311 observations right here, right? 311 employees across 36 columns, 36 variables. Remember, I had to copy the code because remember what we said, we try different things. Once we know what code we want, we always save it to the script. You need to do this for your assignment. So when you are opening a homework assignment and you import the homework data set, you must copy the code to import the data set and paste it here. Okay? So I expect you to do that. I expect you to have library READR. We'll get to what that does later. HR, so this is now use the function read underscore CSV to import this argument into the object HR underscore dataset and then view that dataset. Okay. So make sure you're able to follow on to get to this point. So once again, if I had nothing in R and all I did was I click on these 3 lines of code, I should be able to reproduce what you did, assuming that I had the same file on my computer in this project. Okay. Now, this is where it's a little trickier. So this is where somebody else might say, no, I want you to learn exactly how to code the exact file path. So this is called a file path. I'm not really going to get into that here. If you have trouble with this, feel free to reach out because we will help you figure out what file path to use. And there's other ways, like I said, you could actually click file and import data set here, but then you had to choose what way to do it. And you would find that you should do it where read R is the better option. Base could handle it. And you might say, why is it from text? CSV is technically a text file. That's why you could import from Excel. You could actually hard code it. So you could say, I know this is in the lectures folder, and inside that folder, I know this is the file name. You could do that. You could even change your workstation. There's some work destination file path. There's lots of different ways to do it. Again, I find that this is the simplest. Have your project in one place, and in that place, have the data set or within the homework. Actually, let me just use this as an example. So let's just say, for example, that this data set was in my homework folder. So as an example, let's just say I had a homework 1 data set here, okay? Then to import it, I go to homework 1 and I click import data set. And notice how the code's slightly different. It says in the homework folder, look for the homework 1 file. So that's what I mean by this is a file path code. But I'm trying to keep things simple and not have to teach file path code right now. So you can just focus on get the data set into your R so that we can start doing stuff to it. Okay, so get here. All right. So you have 3 lines of code. We'll come back to what this does. You're importing the data set and you're viewing it. Okay. And there's several different ways to do this. You'll learn that later. Um, if you ever need help on a specific command or function, just type in a question mark before the command function. That's a really just a helpful tip. So if I need help on, I don't know what the mean does for some reason, I can type in question mark mean, and it's going to jump over to the help tab. Remember, I introduced this earlier, and it's going to give me a bunch of details on how to use the mean. I'm not going to talk through this now because it actually can be difficult to understand how to interpret the help file. So I'm just going to tell you to refer to that as a way to think about things. But you're not going to be required to know how to necessarily interpret this right now. Okay, now let's start doing some things where we're going to do the mean, median, standard deviation, and so forth, working with that new data set, okay? Here's some grammar or syntax for working with data sets. You're going to take the object and put a bracket to do a row, comma, column, okay? So let me just show you what it looks like here. So I'm going to take HR underscore data set, right? And I'm going to type in a bracket. Inside that bracket, I'm going to put rows and columns, rows, comma, columns. So just an example, let me look at this data set here. What if I wanted to extract row 5, column 4? Actually, let's do row 5, column 4, 5, 6, sorry, 4, 5, 6, 7, 8, 9, 10, column 10. See that number right there? Row 5, column 10. Then I'm going to type in here 5, comma 10. And by running this line of code, I will get 50,825. Is that right? Yep, 50,825. So do you see how that's how we work with data sets? So data frames, rows, comma, columns. Try this. What happens if I delete this file? Now I've got nothing, comma, 10. Think about it for a second. This will take all rows, but only column 10. If I run this code, I will get all the rows, and luckily, not luckily, but it caps out at 10 rows, but it tells you, hey, there's 300 more rows, and you can use this function if you want to see all of them. You don't need to do that right now. But the idea is now I'm going to get all the rows for column 10. On the flip side, what if I wanted to know everything there is to know about Carol Anderson, row 5? Then I'm going to do 5, comma, blank. I'm going to get all the columns for column 5, for row 5, sorry. So Carol, employee ID, 0, 2, 1, and so forth. So that's one way to work with data frames. The second way to do it is to use the $ and to type in the column name. So luckily, RStudio is pretty intelligent. It tells me right away, oh, here are the column names. Which one do you want? So you can click on it here, or you can just type it in yourself. So what this does is it gives me all the rows for column salary. And it pulls it up, and this one actually just does it so that you can see all of it at once. So it's the same thing as the blank comma 10, but it just pulls it up differently, and it's because it's a tibble versus a data set. It's, again, little nuances that we won't worry about right now. But the idea is the same. It's showing, this one only shows 10 rows out of 300. This one shows every single row out of 300, 311. Right, so I mean, look at the first two numbers, 62, 104. If I go here, 62, 506, 104, 437, 69, 955, right? So it's pulling all the numbers in the salary column and all out of all the rows. Okay, try this line of code. Mean of HR data set underscore salary. Oh, sorry, just to show you, notice that X is telling me there's something wrong with your code. So this is kind of helpful. RStudio is highlighting for you that you forgot to close that bracket. And now once I save it, it goes away. So what am I doing here? Just think with me logically what I'm doing. I am taking the mean. You know what a mean does now. Of what? What am I calculating the mean? I'm taking the mean of all of these numbers, right? Because that's what this code does. It says I'm going to take all rows in the column salary. I'm going to get one vector that has 311 salaries, and I'm going to get a mean of it. So if I run this code, my mean is 69,020.68. And if you remember from last video when we did this in Excel, it's the exact same number. So now try telling me the median. Think for a second, try to do this yourself, actually. Okay. Median of salary is what? HR data set, $ salary. Run that, 62,810. What about standard deviation? 25,156. Let's do a summary of HR data set under $ salary. Oops. There's my minimum, first quartile, median, mean, third quartile, maximum. Right? So you're starting to see how quickly you can do things once you've got that data set imported in R. Okay, what else do I want you to do? So that's with salary. Now I want you to try using frequencies. So go ahead and I want to know what we're going to do a frequency table. Remember, those are used for nominal and categorical variables for race description, DESC, race description. And remember my previous video, you should always learn exactly what these variable names refer to. So I'm going to now type in table. So new vocabulary term. Table gives me a frequency table. It gives me a frequency table, and I'm going to do HR data set, and I'm going to do the race description column. Run that, and there we go. It's a frequency table. It doesn't format it. It's not that great, but I've got 3 individuals who are American Indian and Alaskan Native, 29 individuals who are Asian, 80 who are Black or African American, 1 who's Hispanic, 11 who's 2 or more, 187 who are white. So right away, I've got a frequency table. There we go. So once again, pause if you ever have trouble, and if something's going wrong, double check, make sure you're typing everything in exactly the way I'm typing it in, and then reach out for help if it still doesn't work. You need to be able to follow along to do all of this for your homework assignments. Okay, here's another thing to try. Go ahead and try doing the mean and standard deviation by group. Remember, we did this in the previous video. So try to get salary broken down by race. And here's a new vocabulary term. The aggregate function is one way to do this. One way. There's several different ways to do this. I already said there's several different ways to do anything, basically. The aggregate function takes 3 arguments. The first argument is what are you calculating the mean of? In this case, salary. The second argument is broken down by which group? In this case, race description. The third argument is what function to use, because you could do mean, you could do standard deviation. So to answer the question, what's the average salary among Black and African American employees? To do that, I need to type in aggregate HR data set salary. So that's the first argument. So I'm getting means of salary. Then I'm going to do list HR data set race description. The reason you have to wrap that in list is just because that's the only way to treat it as different groups. It's a long story. I'm not going to get into it here, but make sure you're typing it in exactly as I've shown. And then function, and yes, you have to do capital FUN because remember, capitalization matters in R, is me. So if I run this, I will get Black and African Americans had an average salary of 74,431. Sorry. So you got salary broken down by race. Now let's try what's the standard deviation of each salary broken down by race. Whoops. There we go. Why is this missing? Think about it for a second. Hopefully you have an answer. It's because there's only one person who's Hispanic. You can't calculate the standard deviation if there's only one person because there's no variance. There's literally no difference between people because there's only one person, right? These are the type of the logical things we want you to be able to infer, be able to understand as you get deeper in your understanding of statistics. This understanding of, oh, wait, if standard deviation is about spread and I only have one person, then there is no spread. So that makes sense why this is NA, not applicable, missing. Go ahead and create a histogram of how many employees are in each salary group. Remember a histogram? There we go. So this is now showing I've got a bunch of people in low end of salary and very few people with high salaries. And in future videos, this we're going to talk very soon about what does that actually mean to have this type of histogram. But I want you to be able to understand that and then try doing this. Try doing a bar plot of table of how many employees per race ethnicity. So we're going to do a bar plot and inside, so again, we're throwing new vocabulary terms at you, but bar plot is the vocabulary term to create a bar plot, or bar plot, column chart, whatever you want to call it. And inside, we need the frequency table. So we need to give it a frequency table. So we're going to do, and actually, I'm going to just copy and paste. I'm going to copy and paste this frequency table right here and run it. And there's my frequency table. You might say, oh, wait, where's all the columns? It's because, and again, we'll get into later how this works, but it's just because the text was cut off. And you will learn later how to adjust the column, the picture, make it look pretty and stuff like that. We'll teach you that later. But for now, just be able to understand, here's how you create a bar chart or bar plot, sorry. Okay, you are now essentially caught up on everything that you learned previously about means, standard deviations, medians, frequency tables, histograms, and bar plots, but now you know how to do it in R. So that was the purpose of this video. Go ahead and take a breather, and let's move on to now some new topics for this class.